when you are going to attend any big data interview or SQL interview, definitely questions from these joins they will touch. I know you might have the knowledge, but let me explain my way so that if you are not clear with any topic, then definitely you will get a clarity on that, and also it may be useful in both the ways, like I said, in interviews as well as in real-time stuff. Okay, so today, what I will do up to cross-gen, I will try to explain with the examples. And natural join and self-join is pretty much easy, and you can just explore it. Okay, but the rest of the talks I will try to cover, and then I will try to take any questions if you have further. Okay, so generally to explain these topics, people are using like department and employee tables, and but we can use any table which brings more meaningful data. Okay, here I just taken the two tables. So one table is a product with these columns, product ID and product name and category, and coming to prices, I just created one more table which is prices. Well, in the prices, right, product ID and product price. Okay, in e-commerce applications, generally these type of tables we may see. Okay, so I just taken an example, like these are the sample data I just created regarding the mobiles category, and these are the prices in USD. Okay, like in dollars. Okay, so I already created tables just now, and I just want to show you the data which in the table format. Okay, so here the very simple examples I'm taking, but in real time we may see so many columns and rows, so many rows. Okay, but my intention is to, first of all, we have to understand the concept, then you can apply on huge data, so there's no worry. Okay, so these are the 7 records which are there in our table 1, that is products. And coming to the prices table, that also I want to show you. Okay, so these are the product IDs and their prices in USD. Okay, so these are the two tables that we have. Now we will see one by one the joins. Okay, guys, I already informed that I just started an interview series as well as for real-time working purpose. Okay, so we can discuss the same topics in Hive also, and without any syntax changes. But thing is, we do not have any workbench like this for Hive. Either we have to use Cloudera, but Cloudera is pretty much it will take a lot of resources and a lot of memory, so we may not get this much results faster. Okay, that is the reason I just choose an SQL workbench, but you can execute in a Hive also. But when we attend any interviews, right, for data interviews especially, definitely these type of questions will come from Hive. Okay, since the syntax and approaches are same, so you can utilize these concepts once you get the knowledge. So these are the two tables, and simple. I don't need to explain much here, but let me first of all give you some overview with the figures. Okay, so if you are able to see these two tables, just now we just see the product table having this data, and the prices table is having this data. If you observe keenly, I just highlighted with the yellow color product IDs 1001 to 104 are common in both the tables, but 106, 107 are belongs to table A, but not there in a table B, and 108 or 109 is belongs to table B, but not there in table A, because I taken a data intentionally that to show differences between inner and outer, and left join and right join. Okay, so if the data is clear, then we'll start discuss about inner join. Okay, so clearly, right, inner join is a pretty straightforward and very easy. No need to remember many things. Whatever the common data, between these two tables, we will try to get it as output. Okay. In this case, right, this is the inner join Venn diagram. I just separated, like these are the common IDs, product IDs, and these two are belongs to A particularly, and these two are belongs to B table. But since we are talking about inner join, as usually it will take only common records when we join on product ID, right? So if my query is this, like if my query is this, query means, I just given aliases, okay, the table 1 and table A and table B. From table A, I'm taking product ID, product name. From table B, I'm taking price, because we have to know the right, a product ID and name and price. These are our requirement. So to fetch those records, then first of all, we have to write this statement, then do inner join with table B on product IDs. Okay, A dot product ID is equal to B dot product ID, because we have to join on some column, right, which is init. So in this case, it is product ID. So in select statement, whatever the column that we are trying to fetch, those will be come as an outcome. Okay, as an output, we can say. So here I just chosen only 3. So obviously we will get only 3 columns as an output. Okay, I just want to do one run on in front of you so that you will get a more clarity. See this. Product ID we have chosen from A table, and product name from A table, and again third column is from B table, that is product price. Since we discussed these 4 are common, then we got only 4 records like this. Okay, so this is pretty much easy and able to understand. So I think I hope you do not have any questions on this. Even if you have, definitely we'll try to take once we complete these topics. Okay, and coming to left gen, right? So left gen is is also very much easy. And if you see, when we do left gen, right, it will fetch all the records from left table and matching records from right table. Okay, those the records which are not matching, it will just put as a null values. Like if you see screenshots here, then you come to know. And when you see this Venn diagram, it will be more clear. Like earlier 106, 107 is belongs to table A, and these are the inner joins output. So when we club both inner join and the records which are there in a table A, I'm talking about this. That means in table A, I'm just assuming as a left join. This is a table A, right? So how many records we have? Total 7 records are there, or 6 records are there. Yeah, six records are there. The 6 records will come into our output. Okay, and if 106 and 107 are not part of table B, so obviously we will get for this, right? For this, we do not have prices in a table B, right? 106, 107 is not there in this table B. So obviously, when we do left join, we will get a null values because of no IDs, no products IDs present inside table B. Okay, that is prices table. Okay, that is the reason. If you see, it pull all records from left table, and from right table. If you see, this is only one column that we are fetching by using in left join. Since this 106 and 107 IDs are not part of table B, that is the reason we are getting null values against 106 and 107. Okay, so guys, can you please quickly let me know if you are able to understand these Venn diagrams and the way that I'm trying to explain?
Yes, sir.
All right. Okay, so we'll see the practical, the same queries. Okay, I'm not modifying any query here. Okay, the same query, same query, in place of inner join, we'll try to put left join. Okay? This is only one thing. Okay, I'm not changing anything here because I want to get the same output. I mean, same columns. So that is the reason I'm not changing any select statement columns here. So I'm just changing only left join. Let me run it in front of you. Okay, so let me run it. See, this is the left join, right? See, all the records from left table, that is first two columns are there from table A, and third column matching columns, we are able to see the prices, but the rest two IDs are not present in table B. That is the reason we got null values. Okay, so it is pretty much straightforward. Okay, no need to do confusion. But what I want to say, left join and inner joins are widely, we will use many cases, 90%. We will use the left and inner joins in our real-time project execution. Okay, so rest all the joins, the way very rarely we will use, but these are the two joins which I personally experienced and are using in our projects widely. Okay, in Hive. Okay, so it's very easy, and there is a, we can also left outer join also we can call it as. Okay, both are same. Okay, left outer join or left join both are same, and right outer join, right join are also both are the same. The same way, full join or full outer join also same. Okay, don't confuse. Okay, so similarly, now we'll see the right join. Right join means, you know, table A is left side and table B is the right side, right? Now, when we do right join, then it will take all the IDs or all the data from table B and matching data from table A. Rest all it will show as a null values. If we understand the Venn diagram, right join. See this? This is the right join, right? See, right, we have this many IDs, right? 1012, 104 are the common, and then 108 and 109 are specific to right join, right table. So that is the reason he took all the IDs, and then if you see, this is the output of right join. Third column, we are able to see all the values, whereas 108, 109 are not part of table A. That is the reason we are getting null values for both product ID and product name. Okay, this is the only one difference between left and right. If you see both in one frame, when we do left join, we are getting all the details from left table. When we do right join, we are getting all the details from right table. Okay, if the details are not matching, their nulls are getting populated. Okay, like this. So right join is very, it's very rare, we can say, to use. Okay, but we should have the knowledge on right join as well. Okay, so guys, it is easy. So I hope you understood inner join and left join and right join. Okay, so another one is full join that you know very well. Like full join is the combination of inner join, left join, and right join. If you see, this is inner join, and let us assume this is left join, and let us assume this is right join. So it will populate all the records, okay, with this output. This output in a sense, this is the inner join output. First of all, if you observe carefully, this is inner join output, and this is the right join output, and this is left join output. So we can say this is a combination of inner, left, and right joins. That is called, we can say, this is full join or full outer join. Okay, so whenever you want this kind of data, then only we supposed to use full join. Okay, so We didn't use much in our projects, but yeah, if there are a requirement, definitely we may depend on this full join. Okay, so I can able to explain this by running this code. Okay, this is the code. This is the code. Just only one word change. Full. That's it. If it is right, whatever, it is the right join. Okay, let me write. Okay. So this is the right join. Let me execute right join right first of all. Okay. So the same like output where we see here. This is the right join output. So we got the same output. Okay. Right join output. And since we are discussing full join, so what I did the recently I installed a workbench with the latest version. Uh, I'm facing one error in when I run full join. I'm not sure why it's not supporting, but you people can try in your machine with a different or in the stable version of the software, so that you may get a chance to get output. Okay, so since it's saying some syntax error, but I didn't see any syntax error here. But this is the right way of right way to write a query for full join. So you can try, but the output is like this. We will get output is like this. Okay, when you execute a full outer join, then you will get an output like this. Okay, so it's a this much explanation is enough an interview when you are explain to the interviewer. Okay, and coming to the final join that I am trying to explain today is cross join. Okay, cross join, cross join. Okay, so the name itself, it will give some idea what exactly the cross join. So what we will do, first of all, we'll go and execute the queries, then try to understand. Okay, so I'm not changing anything, and the same query I'm repeating with the only joins. In place of the left or right, I'm just putting at the cross. Well, let me take this. Here, let me take this. Okay, see here, the syntax and all pretty much similar to other joins. Okay, I didn't change anything here. If you observe, I just changed only this word cross join. Okay, so cross join in sense like if we observe the data, what will happen? This 101 will join with all the like how it will come 101 Samsung mobiles, then 66. This is the actually expected, like when we do inner join. But when we do cross join on this product ID, what it will do? This will repeat 101 Samsung mobile 66 is common, and then again 101 Samsung mobiles, and then 100 will come. Like that, how many columns are here or rows are here will be multiplied here. Let us say we have here how many 6, right? Yeah, 6, and here also 6. So it will multiply and will get a output. Let's execute this so that it will be more clear, and let me run it. No need to mention this one. See this, it did cross join. Okay, so what I will do, order by I will do order by product ID. Okay, same output. If you see, since we are pulling only product ID and product name and price, so this is expected. The first one is the actual record. original record, we can say. The second one, all these are copied, same copied, then multiply with the table B values. Actually, this is not correct, but just try to understand how and what this cross gen will do. Okay, just try to understand the concept. Okay, we'll check one more example, especially for the cross join, where we generally use. I will try to explain that scenario as well, but just want to explain how the cross join will work. Okay, so Apple also. So these are and all multiplied. A multiplied B. If you see the number of records, those will match here. So these many records you may see. Okay. So, but what is the use with the cross join? Because we know the use case from left and inner join and right join. But what about the cross join? When we use cross join, okay. So to understand you better, so what I did, I just created one more table called origin. Okay, origin, or you can say manufacturer, or the country. Okay. So in the table, I just mentioned country code and then country name. Okay, and I inserted only one record in this origin table, that is India. Okay, so let me show you this table data. See, only one record, country code and country name. So let us say all these mobiles are manufacturing from India, or retailing from India. Okay, so if I want to fetch those kind of details, when we see only table A alone, you cannot get those details, right? From where it is coming, we do not have the data here. Okay, so then to get such kind of information, then what we can do? We can do cross join A table with, we can say, C table, or B table here, origin table. Okay, so I just written one more query. These are the same. Okay, these are the same in place of product price, right? Because I'm using origin table. Okay, origin, I'm taking origin table. I'm using origin table in place of prices. So my output should be like this, like product ID, product name, and then country name. Okay, this is what I want. So in order to get those information, I'm doing cross join on origin table alias B. I given an alias as a B. Okay, so when you run this, we'll see what happened. See here, this is what I'm expecting. Okay, product ID, product name, country name. So we got expected output, right? All these mobiles are from India only. Okay, so these kind of scenario, we have to use a cross join, like in real time, we can say some pin codes. Okay, pin code is one, but under that pin code, so many areas will come under, right? So in that case also, we can use cross join. Okay, and there are many other cases that you can use this cross join. But I just explained one scenario. But based on the requirement, you can choose which join is more suitable. Then you go ahead and try it. Okay. Hope you understand this cross join as well. So if you have any questions, please let me know on the joins which I explained just now. I'm open for any questions. Just say yes or no. Did you understand the joins which I just now explained?
Yes, sir. We understood. I understood.
Okay.
No questions.
All right. Good. Fine. So don't feel this is a simple topic, because I want to make a playlist of important interview questions as well as the real-time use cases. Many questions nowadays coming from like SQL background. We can say SQL syntax oriented questions, either in a Hive or Spark SQL or Snowflake or SQL, MySQL or PSQL. So this is the basic. So I want to give you this kind of information through this channel. so that after end of a few months or few weeks, definitely we'll have a good material in place in a separate playlist, so that there is many people get advantages from there. Okay, the topics which I'm selecting based on my experience and also experience in a sense, interview experience as well as project execution experience. So hope the same may be useful for you further in both the cases. So don't hesitate to attend calls or attend a session, and please practice it. Though it looks like it is simple, but and when you do a practice, then only you will get a more clarity. Okay, so guys, if you don't have any questions, and I think somebody asking something, is this Gopi Chen? Are you there in the call?
Yeah, Naresh, I'm there.
Okay, Gopi Chen, can you please tell me, Gopi Chen, you showed me some screenshot. What is your requirement, first of all? Can you please show me?
So yeah, my requirement is have a huge data, Naresh,
Okay,
and I'm just applying a row number function. Okay, uh,
just a second,
the
Gopi
use
Chen, just a second. I'm getting some noise. Those who are not speaking, can you please go on mute so that it won't be disturbed for others? Thank you. Yeah, Gopi, go ahead.
So yeah, I have this large cluster, Naresh, and I'm applying a row number function,
All right.
and I'm applying a row number function ordered by two columns. One is ascending and the other is descending.
Mhm.
So I think that is causing a lot of shuffling, and it is taking like close to 2 hours. Is there any way to reduce that way or create some partitions or bucket before only
See,
create buckets and order by that? So
no,
any optimization techniques?
that's what to go change. What I'm asking you, first of all, to do that kind of implementation, right? We need to understand the source data and we need to understand the required output. Okay, proposed output we can say. So let us say you have some millions of millions records and many tables in source, right? But you return a query and absolutely it is working fine in a smaller data set, but when you want to implement the same model on the huge data set, then obviously we may face some performance issue because of huge data as well as the lack of resources that is expected. But to do some performance tuning, right? So first of all, we have to know whether is there any columns which really we can able to do partitioning. Okay, that kind of confirmation, first of all, you have to know. Let us say in your data, you have some date column. Okay, so date column in a
Yeah.
sense, only date column, not the timestamp. So in that case, state of a you can
Okay.
use. Okay, you can use you can create your table, partition table on a date, so that our data will be loaded in a respective partition, and maybe it is easy when we do the processing. Okay, and one more thing. This is one kind of performance tuning, and the second one is you don't know anything, like you don't know what kind of the column that you supposed to do the partitioning. And then I don't know which format that you are using, but I'm strongly recommend you to use Parquet or ORC because Parquet or ORC source tables data I'm talking about. When you because Parquet and ORC will give the better performance when you when you are reading a data. Okay, so if your source tables are not stored, the data doesn't have in the form of ORC or Parquet, so I recommend you to go for Parquet. And first of all, load the data in Parquet format in a source tables, then do all the transformations that you want. This is one other kind of thing. I don't know which environment or which tools that you are using, either in Spark or Hive. I gone through your screenshot. I think you are using Spark. So did you check your RAM and all, or clusters resources versus your whole data which is available in the source tables?
Yeah, it is a huge cluster. There is no bar for resources, Naresh.
Okay,
Uh,
so
this is real time. This is Scala one. The one which I have given is Scala one, Scala code.
okay, well, so
And
now you might got some idea, right? So is there any columns like you can select as a partition?
Yeah. But what I got confused is that are there any primary standard ones? So my data source is from Hive warehouse. So can we store in Hive warehouse the ORC format, or uh, in the source table itself you want me to store in the ORC format, or what are you recommending, Naresh?
First of all, tell me how
Can
many
you
tables that you are using. How many tables you are using?
only two tables? Yeah.
Two tables, right? So two tables. Out of these two tables, which table is more having data?
The output DF, the one which I said, left side of the table, it is having a huge data output DF.
So when you are writing, let us say, if you see my screen, right? So these are few techniques that generally we follow in a real time when we try to execute any huge data. If you see, these are two tables, okay? In your case, also you just assume these two tables are there, okay? First, I return products table, okay? Products table, and the second one is the prices table. So my recommendation when you are using Hive is first of all Hive. When you allow a Hive max join or reduce join, what it will do? Smaller the table which is having smaller data set. First write that statement here. Okay, this statement, this query, I can write like this. You can see this. I will just interchange. I will interchange this, but still I will get the same output. What happened? Okay, this is, we can B and call it as a, see here, we are getting same output, but there is a difference. There is a difference in Hive. Okay, Hive, what it will do, or Impala, I am not sure, but what it will do, first of all, it will take the first table data into memory and the second table data in a disk. Okay, so what it will do, since it is smaller data set, it will, if it's the less than 10 MB, it seems, it will take into the memory, then distribute the data and do the joins with the table B. So since it has taken and loaded into memory, so distribution and transformations are very much easy than doing the normal one. But thing is, when you follow this step, what will happen? Let us say this product table is having 50 MB of data, and this prices table is having 5 MB of data. So since the 50 MB is not fit into 20 MB or 10 MB of a RAM, so obviously it won't apply that rules, whatever we are just discussing. Obviously, we have to wait more time to get output. But whereas this case, right, since the table B is smaller than the table A, then we are straight away putting the table B into memory. Here we are not mentioning anything, but Hive or Impala is smart enough to pick those decision and put it into memory. Okay, so the first from statement, right, you have to put a smaller table. The next, whatever table that you are using, put a bigger tables. This is one of the technique that you can use it. Okay, but in your case, you're saying that you are using Spark, right? These two tables, first of all, see, these are the backend, what type of format that file format that you are using. Is it text file format? Which one?
Yeah, it's in a text file for it is in a text file only, but it is a Hive table.
Fine. See,
It is
creating a
being
table,
loaded
right?
into Hive table.
I know. See, I'm not talking about the writing.
Yeah.
I'm talking about the reading. Okay. If you run this query, that means you are reading data on these first two tables, right? So if this tables, the data is backend text file, then of course it is very slower. What I'm saying, when you create a table, and better you create a table in a Parquet file or a ORC file, and then do these transformations. Okay, I'm not talking about the target table. Okay, target table could be anything, but I'm saying source table data should be backend Parquet or ORC to get a almost 50%, more than 50% performance. You will get a better. Okay. All right. You just try it and also search in internet. You may get some ideas. Since we have only 1.5 minutes left, so I couldn't able to explain much, but just practice it or try with these steps. Okay. Yeah, team. Thank you.
Thank you.
Yeah, thanks so much.